Okay, great. So, hello and welcome to today's iTalk on government innovation, hosted by us, the Digital Innovation Lab of the European Commission. My name is Lisa Vogel, and I will moderate the session together with my colleague Daphne Finistarki. And yes, our iTalks on government innovation aim at exploring global best practices and use cases related to innovation in the public sector. And today we will be talking about the European High Performance Computing Joint Undertaking, short EuroHPC, which is a joint initiative between the EU, European countries, and private partners to develop a world-class supercomputing ecosystem. And for this, I would like to introduce you to our two speakers, Oscar Diez, who is the head of sector for quantum computing at the European Commission, and Sabine Mehr, who is the chief quantum project officer at the French National Research Organization GENCI. And both of them will walk us through the initiative in just a moment. Before that, let me briefly go through today's agenda. My colleague Daphne will introduce you to our Digital Innovation Lab and our activities, and then we will move on to the main presentation where first Oscar Diez will present the EuroHPC joint undertaking, and then Sabine Mehr will highlight the case of France, offering practical insights from GENCI. And after that, we will open the floor for your questions, so feel free to type your questions into the chat at any time or just raise your hand at the end. So, and I guess then we can get started. Daphne, over to you for the introduction.
Thank you so much, Lisa, and thanks to our speakers, which kindly decided to join us today. But before we begin, we would like to introduce you a little bit of what we do at the Digital Innovation Lab. So yeah, let's have a look together. Next slide, please. So the Digital Innovation Lab operates under the Digital Innovation Framework at the European Commission, and our aim is to catalyze innovation in the Commission. So basically, we introduced a process for light governments to promote basically the launching of proof of concepts and prototypes. And we are also providing methodologies and tools to boost innovation, but also co-design, because before innovation within the Commission was happening in a very scattered way, in silos. Everybody was like, every single DGs were doing their own project, but these DGs did not talk to each other. And what we tried to do is really to bring these people together and to make them innovate together in order not to reinvent the wheel. To do so, we also created a community, and we operate under no worries. So we have created this community, and we are trying to encouraging knowledge sharing about the innovation areas that we selected, which are the one that you can see here. So we try to foster digital innovation around computing infrastructure, distributed ledger technologies, immersive technologies, and so on and so forth. Next slide. So what we do, so our activities are operated along 3 pillars. We have the iLab, which is about creating, again, a community, creating synergies. So this is both internal and external to the Commission. We have then the co-innovation strand, which is about launching proof of concepts and prototype. It's about creating a governance for it, about creating an innovation registry that I will show in a few slides. And finally, we have the digital pole, which is basically what can the Commission learn from people which are working outside the Commission. So not to stay in our silos, but also learn from what's happening outside, what best practice we can learn. It's about creating partnership with academia and other institutions. And this iTalk on government innovation is really under this pillar, and has, again, the objective of learning best practices from somebody who's outside of the Commission. Like, in this sense, yes, there is a partnership, but still. Okay, next slide, please. We also have physical labs, both in Brussels and Luxembourg, that colleagues can book and use those spaces to co-innovate and co-design. Next slide. And we created, this innovation registry where people have to insert their innovative initiatives. And we also created a visual representation for it, which is this digital innovation dashboard where colleagues can look for initiatives similar to the ones that they would like to develop in order to create synergies with other colleagues. So for example, you want to create and launch an initiative on AI, you can go in our dashboard and look whether other colleagues have already launched initiatives on AI, and spoiler, they have. Next slide. We also developed this data innovation toolkit, which is a step-to-step guide for people who want to launch an initiative based and rooted on data. And we created several tools to help you really develop your initiative. So this is also publicly available on our website. I would say that my presentation can stop here. I will leave now the floor to Oscar and Sabine. Thank you again on our side and enjoy this talk. Sabine, Oscar, the floor is yours.
Thank you. Thank you, Daphne. I don't know if you can hear me.
Yes.
Yes, so let me share, one moment, let me share the presentation. Give me 1 second. No, but can you, one moment, can you see the slides?
Yes, we can see the slides.
Yeah.
Is in presentation mode or?
Yes.
Exactly.
Okay, so you see the, okay, so you see the, because okay. I'm not sure if you can see all the slides or just okay. So let me start. So you can see the full slides, no?
Yes.
Exactly. The one
Okay.
about
So I will start. Okay. So thank you, Daphne and Lisa for giving me the opportunity to present. So I will go. I have a few slides, and I will try to explain a little bit what we are doing at the European Commission, and especially related to the EuroHPC JU Undertaking on supercomputing and quantum computing. And I will go, like, let's say, high level, and my understanding is that Sabine will go a little bit more in detail in one of the initiatives that we are running with GENCI in France. So let me start with saying good to everyone. I'm presenting. My name is Oscar Diez, and I work for the European Commission. I'm working in the quantum technologies unit, and today, as I said, I will go through. First, explain a little bit what is supercomputing and quantum computing, and also everything that is within the framework of EuroHPC and the supercomputing, basically the computers that we are procuring there, and how we are providing, how we are using these supercomputers and these quantum computers from the application point of view, and how are we providing access to the researchers in order to have access to those computers. So let me start with a basic introduction of some of the terms that I will use. So first, when I'm talking about supercomputing, basically we mean here the words, say, most powerful computers, and normally we are referring to interconnected thousands or even tens of thousands of interconnected systems or servers. These we have so many interconnected in order to solve problems that are too complex for standard computers. So this is when we are talking about supercomputers. When we talk about quantum computing, in the other hand, what we are using is the, let's say, strange and powerful laws of quantum mechanics to basically to do new types of computation. So normally these quantum computers will permit us to solve challenges that classical computers are not possible. Even supercomputers will struggle with this type of problems. So I would like to mention, and I think it's a caveat that I would like to put since the beginning, that quantum computers are still in its infancy. So even if you will see that we are currently procuring quantum computers, and we are now talking about at least 10 quantum computers that are being deployed in Europe, they still are at very early stages. So that is something that we need to know. And there were still a lot of developing being done here. So a lot of research and a lot of innovation in quantum computer level. So when we are talking, let's go a little bit. Let's start with high performance computing or supercomputing. So, and what it's making differently from a standard computer. So normally this is not just speed, it's about how we have thousands of processors or servers work together in a massive scale. So normally these are going to be coordinated through specialized software and specific networks that are with very low latency. And the idea here is that we need to think in terms of parallelisms. So the tasks are going to be distributed across different parts of the system, distributed across the different servers, and they will be running simultaneously. So the idea here is the algorithm and application are specifically designed to exploit these parallelisms. And this is what it's doing these supercomputers special. And it's important because the people sometimes they think when they are talking about hyperscalers like all the cloud vendors or cloud computing, they are thinking, but this is that supercomputer. And it's important to distinguish between HPC or supercomputing, high throughput computing, this is another term, and cloud computing. So basically HPC is about, when we are using HPCs, normally it's for running tightly coupled tasks that depend on fast and low latency, as I said before, communication. So basically, we have a lot of tasks that are synchronized with a very fast network. And they depend on each other. So the results of one part of the task depend on other tasks that are running at the same time. An example of this could be, for example, optimizing combustion in biofuels. In contrast, high throughput computing is about running many independent tasks. So, for example, if you have image processing, it will be something that is very good for high throughput computing. So there is not a lot of communication between the tasks. And lastly, is cloud computing normally focus more on having flexibility and accessibility, but usually we are not looking here for very high performance. And normally we are not looking, these systems are not needed for real-time scientific simulations, like, for example, HPC. So let's move now into quantum computer. As I say, we are giving here like very high level information on these technologies. On quantum computing, the global architecture, let's say, that is completely different from classical computers. Normally in classical computers, as you know, they use bits, and quantum computers use another concept that is called qubits that can represent different states at once. I will not go too much into detail because we will be here for a long time to explaining this, but basically just to say that there are different technologies, physical technologies, in order to do these quantum computers that are currently under development. You will hear about superconducting circuits, trap ions, neutral atoms, photonics, quantum dots, and you will see some examples. I think Sabine also will go into some of these technologies. Each one of them, they have their own strengths and they have their own challenges. And just to let you know, we are currently at the European level focusing in all technologies, on available technologies, because we still don't know which of these technologies are the ones that were going to be the best ones, or the one that are going to be successful in medium or long term. I put here a diagram that shows how a quantum computer works together with a classical computer. It's just very high level overview. So basically, you can see the classical part. It's the one that is handling the writing the instructions and reading the results. So you have also, as part of the quantum computer, you have a classical computer. And later you have a quantum chip, that is where, let's say, the magic happens. And there you will have, we will use quantum gates that they will act on these qubits in order to manipulate the qubits. And these qubits will store in what we call a quantum register. So the register, the important thing here is that these registers where we have the qubits, they can be implemented in different ways. This basically is the one that they are exploiting the superposition, allowing to have many values at once in the register in each one of the qubits. Once that we finish the quantum operation, so basically we have done this, apply these quantum gates to the registers. The system, what it will do is to measure the qubits to obtain the final resource. Everything that you will see here, it's happening in a special, normally in special refrigerated enclosure that is used to protect the fragile quantum states that are running in the quantum computer. So as I said, at European level, we are currently supporting all the quantum technologies, and mostly through initiatives like the Quantum Flagship. The Quantum Flagship is an initiative from the European Commission that is basically doing, focusing on research and innovation on quantum technologies. We are basically opening calls at European level in order to do research on different quantum technologies, not only in quantum computing. As you see there in the diagram, we have in almost all the technologies that we can use to build a quantum computer. We have projects as part of the Quantum Flagship. So we are pushing all the possible technologies at this stage. This is just to let you know, this is a long-term investment. It's something that we started in 2018. The idea is what we are trying to do is to bring technologies, the quantum technologies, out of the laboratory and moving into more practical uses, like supporting research and especially early industry players across Europe. As an example, and I will not go too much into detail of the previous projects that I was showing you before that we have been doing during the last years. One is Action, is a project that has already finished, is from the flagship, and the follow-up that is Millennium. Basically, what we are doing here is we are supporting the construction of a ion trap quantum computing. Ion trap is one of the technologies, and as I said, these two projects, the Millennium is the continuation of the Action project, and the idea, for example, here is to go towards a system of more than 1,000 qubits through the EuroHPC. So this is until now what I was telling you is research that we are doing. This we are doing it with the flagship that is part of the European Commission, and what we are doing now through the EuroHPC is we are directly investing in procuring quantum computers. And some of them are, for example, this Millennium project. They have produced, there is a company, a startup that has been created as part of this project that they are selling these quantum computers. And this is one of the quantum computers that we are currently procuring for, in this case, EuroQCS Poland. And it's currently, in fact, it's been installed currently in Poland, in Poznań, in Supercomputer Center. All these, they will be integrated with supercomputers. Another example similar is EuroQEXA that is in Germany, and this is using superconducting qubits. It's a different technology, but still a quantum computer. And this is coming from a company, it's a Finnish company called IQM. And we are not building also only the hardware, but also focusing on the entire software stack. As you can imagine, this is not only a hardware problem. We have all the software on top of it, and we have also the software for the integration with the supercomputers. There are also fabrication processes and everything that is related to the commercialization strategies. So until here, a little bit gives you an overview. So now, what is the purpose of having supercomputers, to have quantum computers? So at the end, as always, is to run programs, to run applications. So the main purpose is to find answers to questions that cannot be solved by experiment or theory alone. And normally, HPC is often called the third pillar of science. So alongside with empiricism and mathematics, so basically with experiments and theory, it's enabling to have discoveries across different science, like the climate, for example, medicine, materials, and more. So, sorry, high-performance computing is as I said, is a key driver of scientific and industrial innovation. And it has enabled, during the last 40 or 50 years, breakthroughs in areas like climate research, new materials, medicine, energy, and aerospace. So almost all the industrial innovation has been in a way or another involved with supercomputer and high-performance computing. So basically, without HPC, many of today's most important discoveries will not have been possible. What HPC is permitting us is to simulate, to model, and to predict complex phenomena that are normally too expensive or too dangerous or impossible to test physically. And you can, well, in fact, I think Sabine can talk also about that, but GENCI or some other agencies, for example, for supercomputer, some of the main starters when they were building supercomputers and HPC, it was to simulate, for example, everything that is related to nuclear reactions. That is not something that you can do with experimentation. So beyond science, also we have other areas like industry and national security, as I was saying. But as you can see, we have also weather and climate forecasting. So we use it for sectors like defense, also in some cases supporting technological sovereignty. And just to, I will talk a little bit now about possible applications, but just to give you an idea that is extremely, HPC is basically extremely important for the Europe's competitiveness and basically the innovation capacity. And it's one of the strategic, let's say, tools, both for public and for private sectors. So now I will not go too much into detail. I don't know later the slides, my understanding is that they will be shared, but they will be also, I think it's going to be shared the video so you can see there. So as you can see here, we have in HPC, we have, we are supporting different range of applications across science, engineering, and industry. In scientific research is, as I said, is used for things like climate modeling, genomic sequences, astrophysics, quantum chemistry. In engineering, you can see, for example, like fluid dynamics, everything that is related to fluid dynamics, material science, biomedical engineering. And in industry, it's things like, for example, financial modeling, big data analytics, or manufacturing optimization, and also, for example, oil and gas exploration. So as you see, it's cross-cutting technology that is going through all the main sectors. On quantum computing, also, we talk about application. It also has a huge potential across many sectors. This is, as I said at the beginning, this is less explored because we are starting, let's say, on this one. We have financed also projects, and you will see, but they're still earlier stages. And for example, in research, it helps to simulate complex quantum systems, particular physics, model chemical reactions, things that are extremely difficult to do with a standard HPC and standard supercomputers. And engineering, for example, you have things that are related to optimization problems or boosting, for example, machine learning. And for business, the same is some of the parts of logistics, finance, drug discovery, climate and sustainability projects. And finally, another thing that I will mention, I'm not too much involved in that area, but I was asked to also to mention, I think it's important, and it's something that in the EuroHPC they are focusing a lot lately, is AI and AI factories. So here what they are doing is combine HPC and AI to tackle new challenges. So I think you have here about this a lot. I will not go too much in detail, but you have in research, for example, climate analysis or healthcare, everything that is related also to digital twins, engineering and infrastructure, things that, for example, cybersecurity or optimize HPC simulations, and for business, everything that is improving the current, for example, manufacturing processes, logistics, or public sector innovation. So let me now go a little bit more about the main EuroHPC initiatives. I will go relatively fast. So first thing, just to let you know, this is probably something that you have heard, that is why the EuroHPC was created at the beginning. The idea here is to create a fleet of supercomputers across Europe. So we started with the petascale supercomputers that are, let's say, the smallest supercomputers, and later the prexascales that we install it in Finland, in Italy, Spain, and Slovenia and Portugal, for example, for the petascale. And we are now in the process of installing the first exascale supercomputers. I think one is going to be the Jupiter in Germany that is currently being built, and another one will be in Paris, if I'm not wrong, in France. And we are now progressing to install more in Ireland, in Hungary, in Greece, and Sweden. So the idea is to have a network of supercomputers all over Europe. As part also of this strategy, and this has happened in the last 2 years, we are setting up what we call AI factories across Europe, and we have done this in 2 rounds. The first one was in December 2024, and the rest are being announced in March 2025. And the idea here is that they will serve as hubs, combining the supercomputing power, big data, and AI services under one roof, basically supporting both the research and industrial innovation. Here on AI factories is just the idea here is to have a one-stop shop and to bring together, as I said, all the needed components in order to have AI solutions. Here we are talking about having the supercomputers that they were already installed. In some case, they are enhancing the supercomputer with more GPUs for having more power for AI tasks. Possibility of also having access to cloud computing, having access to programming facilities, talent development, and specialized data centers that are focusing on AI tasks. And this is done not only at EU level, but also with the national strategies. The EuroHPC JU, these are doing it at European level because they are connecting these supercomputers, these data spaces at these innovation hubs. And at national level also, countries are investing in their own AI infrastructure. They are also investing in skills, and they are supporting also these innovation hubs in order to create an AI ecosystem at both European and national level. So let's now see what is the evolution of Europe's computing infrastructure from the point of view of the EuroHPC. So you see that we are moving from petascale, that I say is the first supercomputers and let's say the less powerful that we have installed, to exascale, and now deploying the first exascale supercomputers. At the same, in the last 2 years, we are also launching the first generation of AI factories, along also together with new experimental platforms. And in quantum, we are started with simulators, quantum simulators, 2 that have been installed in France and in Germany. And now we are installing the first generation of quantum computers fully integrated with the HPC centers. And our next steps are going to create this hybridization, basically these through hybrid systems combining the HPC and quantum computing. Also with everything that is related to new algorithms, new applications that needs to be developed, and the dedicated middleware in order to connect both. So we are hosting, as I say, we are hosting quantum computers in existing supercomputer centers, mainly to create these powerful hybrid systems. And this, we are doing it combining both the existing supercomputers with the quantum resources, the new one that we are incorporated. The idea is that we can solve certain problems, and not all of them, but certain, we can solve them much faster than with classical systems alone, only that having supercomputers. And it also is helping at this stage to support the education and training for the next generation of quantum experts. So the idea is that they have a system where they can practice, where they can use it, where they can launch the different tasks and see what is the result. We can have, basically, we can train and we can help to improve these systems. So what we have done, so you remember the previous map. So now what we are doing is, under the EuroHPC, again, we're also deploying quantum computers across Europe. All of this will be done as part of the existing supercomputer centers. Currently, we have in Spain, France, Italy, Poland, the Czech Republic, Germany, and there are more hosts, so more that are coming. At it will be a total of 10 quantum computers and simulators. I think we have also Netherlands and we have Luxembourg. And the idea here is that each site will host a different quantum technology. As you can see, we try to have as many technologies as possible, quantum computer technologies, from superconducting qubits to trapped ions to neutral atoms. And the idea here is to permit us to explore and develop as much as possible all the different quantum capabilities with these different technologies inside Europe. So here you see some examples. For example, I think Sabine will talk also about this in more detail, but France, for example, is going to host or is hosting a photonic system. Germany and Czech Republic are focusing on superconducting qubits. Italy is working with neutral atoms. Poland is using trapped ions, and Spain is basically using superconducting, but in this case in annealer mode, that is a different type of quantum computer. And the idea here is that these systems, each one of them that you see there, they will be connected to one of the European supercomputers. And the idea is that to create the first whole hybrid quantum classical infrastructure. So here, EuroHPC, as I was telling before, they are focusing on specific key sectors like industry, finance, logistics, healthcare. And the idea here is to have solutions that are both hybrid, classical, and so HPC and quantum. We are developing, for example, so you see here, there are some examples. You are developing applications in fluid dynamics, drug discovery, risk analysis, quantum machine learning, for example, for some areas like medical diagnosis. And the idea here is that this shows how quantum computing can enhance the real world applications across Europe. So applications that most of them, they were already running in this supercomputer, and we are trying to enhance them, basically improve them with the quantum computers. And with this, and I'm going to finish now, how do you get access to these systems that have been deployed or are currently being deployed in the EuroHPC? So we have different type of access or services, and basically they're organized through what it will be calls, regular calls, and normally it's an open and transparent process, and there are different type of access. So let's say you have from benchmarking, that is mainly for testing purpose, performance, or basically testing purposes. You have later development in order to have access to building and optimize the software. You have the regular access, that is the more that the more, let's say, the more popular one that we have for most of the projects is the regular access for large research projects, and we have for some specific cases extreme scale access for the basically very high impact projects. And all these allocations, basically, you can submit, anybody in Europe can submit a proposal. They're going to be peer review, and they will, in order to ensure the quality and the fairness, and they will be approved. And we have a very good success rate now of approvals to access these quantum, so these supercomputers, and soon these quantum computers. And with this, I think, sorry if I was a little bit too fast, we have a lot of information for not too much time. So I would like to thank you for your attention, and I think if you have any questions regarding the EuroHPC, the European Commission, and what we are doing related also to the quantum initiatives, I'm happy to take your questions at the end. Thank you.
Thank you, Oscar. I think we can go directly and give the floor to Sabine.
Thank you. I'll try to share my screen. Does it work?
Yes, we can see your screen.
Perfect. So thank you very much for the opportunity. Thank you, Oscar, and thank you, Lisa and the team for the opportunity to present what we are doing with EuroHPC and a bit broadly on quantum computing in France. So my name is Sabine Mehr. I'm responsible for quantum computing related projects at GENCI, which is the French HPC agency. So there's a bunch of logos here, but I'll try to explain. Just in short, explaining what GENCI is about, what we do. So we are a French company that operates solely using public funding, so either national or European public funding. So we equip 3 main national supercomputing centers in France. 2 of them are located in the Paris region. So the 2 that you see on the left of the screen, and the 3rd one is located in the south of France, in Montpellier. So the first national supercomputing center is the CEA's. It's in the south of Paris, and it's called TGCC, and it will be the hosting site for the 2nd European exascale system, which will be called Alice Recoq. And it's also, as a matter of fact, the hosting site for the EuroHPC quantum computers that will be hosted in France. So one with the HPC-QS project, and the other one with the EuroQCS France project. I will get back on that. The second supercomputing center is the CNRS-1, and it hosts the GENCI system, which is more dedicated to AI, so HPC and AI converged system. And it hosts more than 1,000 AI projects per year now. So it's been a huge success, and it's also thanks to the team, the support team that was gathered by CNRS to support AI communities in porting their codes onto the system. And the 3rd one is, so it's called Adastra, and it's hosted by the CINES, which is the French University's supercomputing center in the south of France. It's our latest acquisition so far, and its specificity is that it presents AMD architectures both for CPUs and GPUs, and it was our latest step before the French exascale system. And it's a very energy efficient system, so it was ranked 7 on the Green 500 ranking. And so far we are allocating a huge number of hours on this system, so more than 3.4 billion computing hours in 2024. And these systems are freely accessible for open research in France mostly, but with Alice Recoq, there will be a European exposure to the system. So focusing on quantum computing now, which is more my field, we are mandated by the French government for the French National Quantum Strategy to steer with CEA a program which is called HQI, which means France Hybrid HPC Quantum Initiative. This is a program that has 2 main pillars. One of them is about providing an HPC-QC infrastructure, such as the ones described by Oscar in his presentation. And the second pillar is more focusing on R&D to couple HPC and quantum, which is not trivial at all, and also to support the use of these systems to make sure that users are well supported, and to also make sure that we disseminate the information that there is such a platform available. So the French platform is first based on Joliot-Curie, which is a GENCI system hosted and operated by CEA at TGCC. But later, when the procurement for Alice Recoq is completed by EuroHPC, it will be the host supercomputer for the quantum devices. And so at GENCI, we're responsible for the procurement of the quantum systems for this platform, and we're also responsible for dissemination and end-user community support. And of course, we work a lot with CEA, but we also work with other partners such as Eviden, CNRS, and INRIA, and lots of them in France. So here is an overview of the HPC-QC hybrid platform. So as I mentioned, it's being hosted by CEA. At first, what was very easy to provide was some software services. So the companies that we work with at the moment, Quandela, Pascal, and Eviden, they have these softwares these environments that actually simulate the behavior of a quantum computer to help end users get acquainted with what it means to program a quantum computer. So at first it was easier to start deploying these environments so that people learn how to play with photonic quantum computing, with neutral atom quantum computing, and with more broadly the mathematical logics between quantum computer. So this was the first step, and it's already available on our platform. We are also so currently deploying, and I will try to remove the sound of the video. So we have this time lapse running so that you can see the installation of the first system, which is a 100 plus qubit neutral atom system provided by the French company Pascal. This is an analog quantum computer, so it has a very specific way to store the information and to compute. And it was co-acquired by GENCI and EuroHPC in the context of the European project HPC-QS. That I will describe later on. It's hosted at TGCC, so that's the room the quantum room that you can see on the time lapse, and it's accessible for European and French open research. So it will be very soon once the deployment is completed. So as you can see, it's quite advanced at the moment, and so it's a matter of weeks now. The HPC-QS project was one of the first milestones that were described by Oscar in terms of procurement and equipment. It's led by Jülich. They are also acquired a Pascal device, which is the twin of our system, and it gathers 15 partners in 6 countries. So our system is called Ruby for Rubidium, and the Jülich system is called Jade. In the context of the HPC-QS project, some partners are working on use cases to exploit the specificities of analog quantum computing relying on neutral atoms. But this is the first system that you will have access to. The second one is called Lucy, and it's the second quantum computer in our HPC-QC platform. It's a 12-qubit single photon powered system provided by Quandela. It works in digital mode, so it's different from the previous one. It was co-acquired then again by EuroHPC and GENCI in the context of the EuroQCS France project. As Ruby is being hosted at TGCC and integrated with Joliot-Curie. And you currently can request remote access to the same device that can be provided through GENCI and CEA by Quandela for your research. So don't hesitate to connect if you want to have more information on how to have this access. About the EuroQCS France project, so it was the name of our application to the call for expression of interest by EuroHPC. So it was the first wave of acquisition of quantum computers. We gathered 5 partners in 4 countries with a budget for the acquisition of 16 million. And it led to the acquisition of Lucy, and it should also lead later on to an upgrade to a 24-qubit device. And we were also asked, and I will present that here, by EuroHPC to join forces. The 6 hosting entities and the 6 acquisition projects that were presented by Oscar were requested by EuroHPC to join forces to try to harmonize the way that we integrate our supercomputers with our quantum devices. And this led to a project coordinated by GENCI, which is called EuroQHPC Integration. It's a project that will last 48 months, and that should lead to a harmonization of the user experience on these HPC-QC hybrid platforms. So we have a structure that is actually quite standard of what we try to put in common between the 6 projects. There was a lot of effort between the 6 hosting entities to find some common grounds on the harmonization. But we also try to keep some specificities to also explore different paths towards HPC-QC integration, and also to have some feedback from one another to make sure that we that we are trying to find the best way to perform this integration. So it was launched during the EuroHPC summit in March this year in Krakow. And so we tend to acquire ourselves, or to acquire through EuroHPC, but as a hosting entity, the quantum computers. But we also wanted to take parts in other projects, and that's why we decided to join forces with SURF when they applied to the second wave of acquisitions. Through the EuroSSQ HPC project, they applied to host a spin qubits technology and to integrate it with the Snellius supercomputer. The tender for this acquisition should be issued soon, but they were already selected by EuroHPC. And we contributed by investing in the infrastructure. So we also contributed to the technical part of the tender. And the CEA, as a partner of GENCI, will also contribute to the HPC-QC integration of the device. So this is another perspective that we have on how to integrate this European community. And so now, what will be done using these devices? So Oscar already mentioned a bunch of applications. So of course, we know that these quantum devices will not replace HPC because they don't have the same field of application, but they complement themselves. So they complement each other. So we have this initiative that is led by the Paris region so far, which was a pilot one launched in 2020, and which has been quite successful so far. So they co-fund some exploration projects that put together an industrial player that has a use case, a business use case that they want to solve using HPC-QC or using quantum computing. And we try to match them with quantum experts from startups and from the academia. And they perform these explorations together for 18 months in average. And the quantum expertise in these projects is being co-funded by the region. And what is interesting to see is that you can see some very renowned French quantum startups here, but not only. We've also included European players such as Multiverse Computing or IQM, for example, which is a very, I'd say, strong asset for this ecosystem, is that we're also trying to play at the European level. And so the use cases are in various fields. So you have drug design, energy, optimization of industrial process, finance, but also some use cases that were really important in the HPC area, such as combustion, the modeling combustion, for example. So these are very interesting projects that should lead to interesting results. And we were very pleased by this model. So this is why we are trying to expand it to other regions in France, where you have other industrial players that might have some different use cases to bring to that table and to try to explore them, leveraging the HPC-QC platform. And this is also why we launched the network of the houses of quantum. We relied on the example of the Netherlands, for example, or the innovation zone in Sherbrooke in Quebec, because we saw that there was some room for collaboration also in the regions. There was some very specific expertise that could be leveraged and promoted more broadly. And so we selected 5 co-localization projects in 5 different regions. So the Paris region, in the east, also in the Nouvelle-Aquitaine region, near Grenoble also, and in Occitanie, so in the south of France, where they have projects that actually complement each other, where they will host specific HPC-QC related communities, and they will also try to launch joint initiatives to make sure that this expertise is also well spread across the houses of quantum. So it was also a way for us to leverage the use of the HPC-QC platform. And last but not least, we are also responsible for dissemination. There is a very big event every year in Paris that actually gathers the tech community, the international tech community, and we host the only fully dedicated, only fully quantum dedicated booth in this event since 2022. And since 2023, we have been hosting startups on the booth from our French ecosystem, but also from throughout Europe. So, and it's been very successful because we've had visits from high-profile personalities, and we've also been able to welcome communities from other topics, related topics such as quantum communications, but also quantum safe cryptography. And so if any one of you is attending Vivatech this year, we would be very happy to host you on the Quantum Zone. And with that, I think I'm through. So I would be happy to take any question. And again, I'm very thankful for this opportunity to present what we are doing.
Thank you, Sabine, for your presentation. Looking at the time, I will just directly open the Q&A session. So please feel free to ask your questions either by writing in the chat or by raising your hand, and then we can also unmute you and you can ask your questions directly.
So I don't see any questions in the chat yet, but don't be shy. It's a very cool opportunity to talk with our speakers. So I invite you to ask your questions. Well, in the meanwhile, maybe I have a question. I mean, it's more a curiosity because at the Digital Innovation Lab, we would like also to foster this kind of environment where academia and startups meet up with European institutions. So I would like to know maybe from Sabine a little bit more about how you manage this whole process and what the results, some of the results of this cooperation were, even though you introduced it a little bit, it would be nice to know a little bit more. I find it really interesting.
About the use cases?
Yes, about some of the use cases and also the process of gathering these people together. And yeah.
Okay, so the Paris region, they are the ones who co-fund these explorations, but as it's a very, well, it can be tough to try to identify these projects. So at first they decided to rely on other organizations such as GENCI. We were very much involved in the ecosystem, and we had this technological watch initiative also that helped us identify these opportunities. And so at first I'd say we were proactive in knowing, okay, we have Total Energy, we know that they are doing HPC, they have been for a while, EDF the same. So we'll go to them and try to explain what the opportunity could be, and then we'll try to identify amongst the ecosystem which would be the players who would have also the ability to take on such projects. Because for startups, it can be also, sometimes it's a bit early to engage in such projects. So we also needed to have more information on that. And so at first, there were mainly French companies, but we were also in contact with the attractivity agency of the Paris region, and they were trying to attract some European companies to set up offices in the Paris region to also enhance the attractivity of this region. And so that's also one of the, I'd say, one of the main motivations for to launch such projects is also to try to attract them to this territory. And so this is also one of the ways that such projects emerged. So either from the will of the industrial player or from the will of the startups to engage in projects in France. And now what is super interesting is that we receive directly some requests, some from some of these players. They come directly to us because they've heard of the opportunity, And sometimes they already know with which startup or which experts they want to work, and they want to know how to proceed. And what was also interesting was to see that at first it was more the energy sector, and some very big industrial companies. But more recently, we've received attention from the banking industry, which was a bit shy at first. And so we are really hopeful for future projects in other industrial fields.
Yeah, that's like the energy sector is also driving, I think, in Italy, from my knowledge.
Okay.
We have this company which is called Eni, which is a very big company which is cooperating with Leonardo, the supercomputer of Italy. So it's often one of the
Usually leading the way. Yeah.
Yes. Thank you very much. Very interesting. So I don't know if anybody else has some questions, or maybe they want to enjoy the lunch break. I don't know.
I think otherwise, since it's also like already past 1:30, we can just share our next events and continue. Or what do you think, Daphne?
Yeah, sure. Let's proceed this way.
So let me just quickly share my screen. And if you still feel like you have questions, please still go on.
Yes.
But yes, so I hope you can. I even can't see my screen yet, so just give it a minute. Sorry. Okay. Can you see my screen now?
Yes.
Okay, so we have a couple of more events. These ones are unfortunately only for the European Commission staff. So we have our co-innovation iTalks, and where we will showcase innovative initiatives from inside the Commission. And then we have also our Date with Data, which is open to all EU institutions and agencies, where we present our book talks. And then another event only for European Commission staff, I'm sorry, will be our VR Days 2025. We will open the registration for that soon, so please stay tuned. And our next event, which is also open to all, will be our next iTalk on government innovation, where we will have the World Economic Forum and the Global Government Technology Center in Berlin. And yes, we would happy to see you there. Otherwise, if you want to maybe showcase one of your government innovation in one of our iTalks, please reach out to us. You can see your functional mailbox. Otherwise, check our webpage for events. And yeah, I think then at this point, I will also release you now to have and enjoy your lunch break. Thank you very much again, Sabine and Oscar, for all of your insights on HPC. And yes, I think if there are still questions from the participants, they can probably also reach out to you directly. And yeah.
Thank you very much also on my side. It's been very interesting.
Thank you. Bye.
Thank you. Have a nice
Forward
day.
to future cooperation with you. Thank you.
Bye.
Bye bye. Enjoy the lunch break.